Number 3, the span is going to be 160 foot for the gymnasium. The engineer has suggested a few options. Which of the following rings true? The trouble with precast concrete will be transportation logistics for such a long span. B, open web steel joists will give the strongest and stiffest long span structure. C, glue-lam wood systems would clearly be the most economical. D, the advantage of post-tension concrete is very low formwork costs. So this is talking about a bunch of different possibilities for doing a long span, 160 foot long clear span element. And each one it's claiming a certain aspect of either strength or difficulty with a different type of system for the long span. Are there any that we can very quickly get off the plan here? Well, one that jumps out to me, maybe this may not be something you've dealt with very much, so I don't know if it's something that has come up for most of you, but glue-lam systems are just not easily economical. They tend to be very specialized and they're beautiful. I'm a huge fan of glue-lam systems, but they're definitely not the most economical way of dealing with something of this kind of span. That's a pretty long span for glue-lam, although doable, and it would be a lot of effort to make something like that work. So I'm going to just say, all right, glue-lams, that's just not economical. That's not a reasonable answer. And then let's look at a couple of the other ones. How about open web steel joists? Well, open web steel joists are absolutely economical for that kind of span. It'd be a pretty deep steel joist, but they could handle it with the deep open web. So that's a very economical choice. However, it's not going to be the stiffest choice, and that's what it's saying there. Remember years ago, the sort of mid-late 90s, when the first IKEA opened in our area, and happened to be there on opening weekend, and it was packed. It was filled with people. Everybody was like really excited to have the first IKEA in the region, and so literally filled with people. And I thought, oh my God, I'm going to be at the Great IKEA disaster of 1997 or whatever year it was. The floor was bouncing so much from so many people walking on it, and that was because it was just overloaded. And they're perfectly strong; they're just not stiff. Those open web steel joists. And so they just, shouldn't have that many people on it because it just was crazy. So B, not a reasonable answer, because stiffness is not the big winning thing for the open web steel joists. Economical, lightweight, you can run ductwork through them. There's a bunch of advantages to them, but stiffness is not it. So then that leaves us with A and D. Let's see what D says. The advantage of post-tension concrete is very low formwork costs. So what is post-tension concrete? Well, post-tension concrete is when you effectively build a formwork system that spans the entire distance for this long span, and then you lay in some post-tensioning cables, and then you pour concrete into that formwork. And then once it's started to set, you use hydraulic jacks and pull on those cables. And it's a very, very strong system. So that great big long system that I've got these cables running all the way through. I've got the jacks on either end. I can make these cables very, very high tension. That's going to give this whole thing a little bit of camber. So it's going to reach up now, and that's going to be very, very strong structure. However, that is not going to have low formwork costs. That's a lot of formwork for that one beam. So D, not it. So that leaves us with A. The trouble with precast concrete will be transportation logistics for such a long span. So imagine you've got a place where you're making the precast structures that are going to span this distance, and I've got 160-foot long precast elements. How are those going to get to the site? Maybe through a helicopter, but like the longest trucks you can get are probably about 80, 90 feet. So we're a good 60, 70 feet longer than the longest regular trucks. You can get specialty transportation and figure out some way to do it in the middle of the night or something. Maybe you can kind of easily go up to 120, 130, 140. These are very, very big elements. Imagine you're trying to get that through a city street or something. So long span with a precast, that's always going to be the issue. One of the reasons that precast is often used for reasonably long span for parking garages, because the parking garage spans tend to be about 60 to 80 feet, kind of roughly in that range. Well, 80 feet, that'll fit on the back of a truck, a long truck, but it'll fit on the back of a truck. As soon as I start getting up into that 100, 120, 160, that becomes a really big problem. So what's being asked here is just that you have some fairly basic ideas of the process, the economy, the sort of desires, like what are the benefits and what are the negatives that I get out of each of these different systems.
Wow, that was a tricky one. We got we had about 120 some people answer questions, and you knocked about 90 of them out with that one.
Well, good job on those that got in there.
Kyle asked an interesting question. He says, in the post-tension beam, do they lay the tension rod flat or with an inverse arc to the camber?
They usually, so there's two things. There's a bunch of ways you can do it, but the sort of classic one is that it's actually more like a tendon, so it's like a cable, sort of a thick cable, and so it would have an arc in it, sort of parabolic, catenary, whatever arc, and then when they pull the cable, that tendon, it goes towards flat, and that's what lifts up the camber. But it doesn't have to be that. It can actually be reinforcing bars. So they're solid bars and they just still get pulled. And then what's happening there is you're not really doing, it's not changing the shape as much in that same way. It's more that you're putting the concrete directly into compression. The whole point on both of them is to put the concrete into compression, but with a solid bar, it's more about putting it into compression. With the tendons, it's more about changing the shape into that camber.